We're recording now. So today we're
Okay.
debugging what the fuck is wrong with the lists.
Right.
So I think the first thing we should put back on the example. I think actually I committed with the example.
Yeah, it's here.
Yeah, and then it doesn't work. So let's put a debug somewhere and see what the fuck happens.
Uh, just for. Oh, okay. Yeah, this is not unifying for some reason.
Wait, but that's a different problem, right? I actually don't remember. How were we identifying the problem?
Uh, let's see.
Oh, line 16.
Yeah, this one. Oh, actually, yeah, same issue as the other one. Oh, these are actually equivalent. Never mind.
Yeah, so x is not a free variable, right?
It shouldn't be. No.
Yeah, but if you make an equivalent example using successors instead of lists, it works, right?
Using successors instead of lists. If I do.
And if you do
Yeah, if I do
successor,
like.
successor of new, and then x is gonna be successor, successor of new, right?
Yeah, if I do something like this, right?
I haven't tested that one, but we can try.
Yeah, this.
This is
No, this
also a
doesn't
free
work.
variable.
Huh.
Wait,
Okay.
wait. So our functors are fucked. They don't work with multiple arguments.
What
Only
do
if
you
it's a
mean?
single argument. Yeah, if we use like a functor with only one argument, like we were doing before, like successor of new. That
Hmm.
worked before.
Actually, there's one thing we should test just as a sanity check. Um, and that is if I copy this and I switch to master, of course, I switch to master and I make a very simple example. Actually, let's just call it EQ because that's what we're doing. EQ of A, and then main ML.
We're going to
If we
see
go
if we didn't
to,
introduce the problem, right?
yeah, we did actually.
How? Put a more complex example there. Swap the entire cons with x, the final cons. Yeah. Yeah, I don't know what to say. So we introduce it. We can go over the diff then and try to see if we fucked something over. That's that's actually better. I wonder how we fucked it up.
Hmm, add constant. Actually, there's one thing we should do, in fact, before we go into this rabbit hole. We go back to master for a second. And let's put a debug here.
Sure.
Well, of course, I need to actually main ML. It needs to go to not factorial, not lists, but EQ.
Mm-hmm.
And then let's actually print the code that it generates.
Now let's save that in a buffer. Then let's pick the same example in a new
Uh,
branch and compare. That's an awesome idea.
yeah, and then the other one is
I think maybe
halt.
lists. Oh, halt.
Git
Interesting.
switch lists. And then this goes to EQ. And then we do Dune exec Karuta. We print the code.
And now we
And then
compare.
we have the two. Yeah, now we have the two side by side. So
Okay, everything starts with a set constants. That's good. It's already different.
because we switched nullary functors to be atoms, right? We have a dedicated construct for that now.
Yeah, but I don't really remember what it does. I guess that's okay. Then we do cons 2, 4, set constant. And then on a new one, we do a set value. But in here we do a set constant. We're doing two set constants. Is that correct? I have a feeling that should not be correct. Shouldn't it be
Two
the
set
put constant?
constants.
Yeah, shouldn't it be first put constant and then set constant?
Where?
On the right. We're doing with the
Well,
atom new.
but where on the right?
Lines 5 and 2.
Yeah, 5 is a set constant and 2 is another set constant. Okay, on the left side,
It's a
one is a put
put
structure
and the other is a set
and
value.
the other is a set value. And the other is a set value. Hmm.
Does that matter? Or in your opinion, it doesn't matter?
Set constant integer 1, set constant integer 2. Then put structure new, put structure cons.
Everything else is the same. I already read all of it.
I'm not sure that this is right actually.
The one that works? Damn!
Like, we're doing set constants here, but like we don't have. Hmm.
Hmm.
integer 1, integer 2, and then put structure new on x6. Then we do a put structure. Then
Yeah,
we do a set constant and a set value.
the only difference is 2 and 5. Everything else is the same.
Then we do another put structure, and then we do set constant 1, set value. Then we have another set constant and set variable.
Yeah, which is also true for the other case. Hello, Magit.
Hello, Mageta.
So yeah, so the set constants are fucking us over, essentially.
Ah, man, I was muted. Sorry.
Yeah. How was your lecture?
Man, I'm
We are
super low
recording, by the
energy.
way.
Okay, I'll tell later about that, but yeah.
Was it good?
Yeah, it's ending actually. I think next week.
Is that the one
It's the
about learning a new language?
uh learning a new language.
Yeah, not programming language.
No.
Okay,
Was I learning? Well, I mean, I was learning, but that was like by myself. That's with an actual professor, right?
I
It's like
see.
grammar and other stuff.
No, so it is a lecture about grammar.
Yeah, but it's
Awesome.
like general grammar, right? So it's not like really linguistics, you see? It's like
That's
philosophy.
awesome. Yeah, well, okay, so let me keep you up to
I
date
have
to
a
what.
question about dependent types, by the way, but I'll talk about that later.
Okay.
What we're doing now is the following. We noticed. Okay, so lists are bugged, but before that, Marinho made an example. Can you show the
Mhm.
example, Marinho? I think that's going to be productive. So this example here, it works on the
Mhm.
master branch, but it doesn't on the list branch. So whatever we did, we fucked it up really hard because this has nothing to do with lists. This is just a bunch of functors.
Mhm.
And we have on the left the code from that is being generated from master, and on the right we have the generated code that we are on the new branch, and we're trying to figure out the differences to see if we can find a problem. That's what we're doing.
Yeah, we
Okay.
can ignore this because this is exactly the same on both sides.
All of them is exactly the same on both sides, aside from 2 and 5.
Aside from 2 and 5.
Yeah,
Um, 2 is a set constant, which is actually wrong.
that's the problem then.
Yeah, it should be a put constant actually.
Yeah, that's exactly the question that I asked you. Shouldn't it be a put constant first and then a set constant after?
Yeah, it should, but yeah, this is also wrong actually.
Why?
Like, there's no reason to do those set constants before we start setting up the arguments.
Is that in general or is it just for queries?
In general, like, set constant is something you do when you're constructing something with method values, like a functor in general or a list in particular, right?
Okay, so let's grep for set constant in the code generator and let's see what the fuck we're doing. Three places
Uh,
only. Fun.
this is one of them, and
Okay, so we have three instructions for constants, right? We have set constant, unify constant, and put constant. Should this be a put constant?
um,
This is an emit single queued argument.
no, because the other side has unify variable and unify value. This is for the contents of something, a functor or a list.
Yeah, so we should go to the next grep then. We only have three places. So okay, so this I don't remember where this is, but this is in Yeah, this is in the gigantic body that we have to care about the order as well.
Yeah, this is not the one. So it's probably this.
Which also seems not like it, but okay.
Hmm.
Are we
Hmm.
doing put constant anywhere? I have a feeling we're not using put constant.
We
Oh,
are
we
actually.
are. Oh, we are. Okay. Okay. Yeah, but this is not the place, right? We should not be doing set constants. We should be go back to the set constant cases.
Yeah. This one is emit body.
And this is for a functor.
Yeah. Okay. Set constant.
Yeah.
Not here.
Three
Not here.
places.
Well, this is a candidate, I guess.
Your screen, I think, has frozen because I'm still looking at the grep results.
It looks fine to me.
Wait, so
Well,
you?
it works on Mageta's machine.
It
Okay.
works on my machine.
Okay, I will kill the stream and watch it over.
Generally, that's not the case, by the way.
Oh, it is working now. Okay, that's weird. That was very weird. Okay. Okay, so which one of those is wrong? How are we gonna understand that?
I mean, we can just try them out.
That's awesome. We have three places. One of them is wrong. And oh, probably put constant receives two arguments. Maybe.
Oh, because this is unify, and the argument type is not the same. Hmm.
Yeah, so you probably have to extract something out of the V. What is V on that case? 127.
Well, if those are get structure and get list, what if this is supposed to be a get constant and this is supposed to be a put constant?
Symmetry, right? Always works.
But then why are these unifies? That doesn't seem to make much sense.
Yeah, it's wrong in 137. It's the LSP is also telling us that.
Uh,
Ah, I know why. It's because the types are now not matching. And before they
add
were.
constant, const.
Yeah, it's because the const function on 137 is not matching the argument. Yeah, that's the problem. So
This takes
these
a
receives a
constant and a
register.
register.
Yeah.
This takes a register.
Yep. What is the type of V then? Like you see on line 126 where we
It's
are
a
just.
pair.
Yeah, but what do we need for the get constant? Another pair? A different pair?
Uh, oh, this is a constant and a register, and this is also a constant and a
No, no,
register.
no. What does the get constant need? That's the question.
A constant and a register.
And what about put constant?
Same thing, Lemos.
Wait, so I'm very confused. What's the problem? This expression should not be a constructor. The expected type is. Oh, you need to make a tuple out of those things. That's the problem. We have a register
Mm,
120 though. Maybe you can use that.
emit single queued argument.
Yeah, we actually have a raw register and a register. I'm gonna bet we're gonna use the raw register for this one. Oh, actually not even. 151 for example. We're doing the register, not the raw one. Yeah, try adding the register there. Easy enough.
Okay.
So just put comma after the int and then do type register. That's it.
Just one moment. The instruction is variable register, value register. Variable just takes the register, nothing else. And value also just takes the register. Yeah, they always take a register. So in fact, yeah, in fact, we should do basically this, right?
No,
Um,
these are for variables and variables that we've seen before. We don't have the semantics with constants.
no, it's for registers actually.
No, it's for variables and values, as you can see on the instruction. We are using the registers, the defined optone registers, to see if it's a variable or a value. If it's a variable we haven't seen before, then we use the variable function. If we have seen before, then we keep the register map the same and use the value function.
Mm,
As far as I can tell, this is not necessary for constants.
yeah, the instruction is the same for both cases, actually.
Yeah, so just put after the int and the nameF the register, man. No,
Mm,
you don't need that. We already have it in 119 and 120.
119 and 120. But
Yeah.
they are lazy lemons.
Ah, I see. I see. I see. I see. I see.
Do we care about the raw register? We don't actually, I think.
Just put the register after the nameF. Same thing above. Now I type checks. I don't know if it's correct.
Mm,
175. Oh, we changed the arguments. You need to change, yeah, you need to change the type of the const argument for this function. There's a cascading effect going on.
but in this case, we actually do want to use a set constant.
You can just replace it. Replace the const with a new lambda. Or you can just use shadowing and make a let above this one.
Mm, set constant v.
Yeah.
Yeah, that's kind of not great, but let's see. Exception not found.
Yeah, the best of the bunch. When a map that was supposed to find something didn't find what was supposed to be found. Awesome. Very awesome.
Hmm.
Well, what are we gonna do? Well, if you're gonna pass the set constant down there, man, I think we should just hard code it in the callee instead of just passing it as an argument. It made sense before to make it as an argument because we were using it 3 times. Now this is hard coded in 175, so we don't need to pass it.
Yeah, no, actually that doesn't quite work because this could have been a unify constant instead in this case.
What do you mean? Why that's the case?
Uh, just for trying it out, I'm going to do this. And this is set constant. And this is get constant. No, this is unify constant actually. And then here is nested, in fact. Still not found.
If that worked, I would be pretty surprised.
Still not found.
I think we should ask the question if it makes sense for these things to be put and get constants in the first place. Because remember, before we were doing set constant and unify, right? I think.
Yeah.
So does that make sense? Should those things be put constants? That's kind of the main question right now.
Hmm.
Let me grab the book.
I have it open actually.
Yeah. I don't remember the semantics anymore, so let me read it.
Is this book for sale, by the way? That's a good question.
What?
It
Warren's
might
abstract
be.
machine?
Because I think it's just a PDF, right? I just saw it as a PDF, but is there a version like in paper?
Well, we're printed from the MIT press, so there might be.
Yeah.
Well,
So
maybe they just say printed, but never was printed.
that's fair. Fair to be assumed. Okay, so puts. Yeah. Place a constant cell containing C into a register. Continue execution with the following instruction. I guess this makes sense. You're reading put list, by the way.
Yeah. Hmm.
Now we should scroll up. We are debugging constants. Yeah, so put constant seems to be correct. When you are introducing a constant, we should put it on a register. That makes sense to me.
Hmm.
Ah.
Yeah. Basically.
Well, we also have to answer the question: should we call a put constant in that place, right? So should we?
Well, we should actually, because this is. Actually, should we? Let me look at the code again. Temp. This is not the one.
This is also not the one. Did you lost it? Did you lose it? No, it's EQ compiled. It is there.
Oh, it's the first one, of course.
Yeah, so let's read this. The first thing you're doing two set constants in a row. Set constants push a constant into the heap according to the book. So we are just saving the constants. Should we do that?
Yeah, we shouldn't do these actually.
Yeah, so since somewhere we are doing set constants that are not correct. So let's start with those. I think that's easier. Let's go back. Let's go to the code generator and restore the file. And let's just go over the set constants, and one of them should do nothing, but we are doing something.
Set constant.
Yeah, so there are three places. One of them we should be doing nothing.
Yeah, but the problem is we need to check like this one for example. Emits argument blah 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 in Q nested if not in query. In this one,
Yeah, we're calling the constant line
uh,
90 and 92. Those are the places. Should we be doing that? That's kind of the question.
hmm,
And let me ask you something else. Why don't we want to push those constants to the heap in the beginning?
because they are not, they shouldn't be there to begin with. They should be inside of the like. Let's actually look at the code, the source code. I mean, like we're constructing this. Well, we're constructing from the inside out, right? So we start with this thing here, this cons, which
Mm-hmm.
contains this shoe and this new, right? So what it should do, in fact, is we need to do first a put structure for the cons. Then we need to do a set constant for the two and a set constant for the new,
Uh-huh.
because this is going to allocate a cell on the heap with the header for the cons structure. And then these two instructions are going to fill in the contents of the
Put
structure
structure,
with
yeah.
the two and the new. Yeah.
Yeah, no, that makes sense to
There's
me.
there's absolutely no reason to do set constants before the cons.
But if you go to the compiled code, just for a moment, we are
Yeah.
not even doing that, right? We are doing the one and the true, but we're also doing the new with the put structure.
No, but this makes sense because this needs to be, well, this is before we added the atoms as constants, right?
No, but you said that you do the put structure first. I think we're doing the inside out strategy here. So we put the numbers first, and then the new, and then the cons.
Okay, let's go one step further because this is nested structure, right?
Uh-huh.
We have a cons inside of another cons. So what happens is, because you're going from the inside out, you have to allocate these cons first because it's on the inside, right?
Uh-huh.
And this is going to be put into a register, let's say x5, just for sake of the argument, right?
Uh-huh.
Then we need to do a put structure cons. This will be a cons2, actually both of them, right?
Uh-huh.
On x1 in this case, or rather x0, because this is the first argument for the EQ, right?
No, but you're not doing inside out. You're
No,
not
no, no.
doing that.
I am doing inside out because then we do set constant
You're not
one,
doing
and
inside
then
out
we do
because if that was the case, the constants would go first.
no, and then we do set value x5.
Yeah. So that's what I'm talking about. The code that is being generated is doing the complete inside out, which means constants first and then the cons in the first lines 5, 6, 7. As you go, put the code on the other side of the other side. Yeah. As you can see, we're doing first the new. and the integers. One of those integers is kind of fucked up, but we have the true and the zero there. The true and the new, sorry. We have the true and the new. And then it comes the first cons on line 3. That's what I mean with
Like
inside out.
like the new is actually correct because this is not this is before we added the change to allow atoms,
No, no,
right,
no.
as
No,
constants.
I understand that this is a constant in the new branch. That doesn't matter. I'm just explaining to you that from the code, the new and the no, and the true is coming before the put structure. The put structure only happens on line 3,
But
not
the
on
new in
line
this
1.
case, well, yes, the new in this case actually should come before because this is a old style, so this is a structure, right?
No, you're not
Like if
getting
new,
it. No, you're not getting it. In
no,
the
no, I am, and the problem is, okay, we have we're actually not even like this is not even being done properly because this is a one, this is from the outer
yeah,
structure,
this should,
right?
yeah, the one is fucked up. I'm not denying that. But I'm trying to understand the true and the new. In the code generated, the true and the new comes before the put structure on the cons. In your example, the put structure on the cons comes first.
Like, let's actually replace this with how it would be in the old version, right? This would be something like put structure new 0 on x, let's say 6, and this would be a set value x6 instead, right?
Yeah. Yeah, but in the new code that we are generating, the set constant of the new, which is an atom, is coming before the put structure, right?
Yeah.
So you're telling me that we should not be doing inside out in this case. We should be doing cons first.
Um. Well, it is inside out, but only if you actually need to allocate something on the heap. When you do a set constant, you don't, because this doesn't use the heap at all. Like the 2
Mm,
in this case, right?
no, the set constant uses the heap. In the book, it's
No, the
saying
set.
push the constant C onto the heap.
Yeah, no, no. I mean, the 2 doesn't occupy heap space by itself. Like it can live directly in a register.
But that's exactly not what the book says. The book says
No, 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 no,
push
no,
the
no, no.
constant into
Lemos,
the heap.
Lemos, Lemos.
Yes.
The point here is that 2 by itself, if you just have a 2, right? If you just have a 2, this occupies a register but not heap space. So it doesn't have to go before the put structure of the cons.
I understand what you said. I'm just saying that the set constant deals with the heap. That's the only thing I want to point out.
Yes, it does, because we're allocating the cons, which means we need to fill the heap with its contents, which includes the 2.
Exactly. Um, okay, so a lot of things are wrong then. Is my understanding correct? Because we're doing two set constants. First of all, I don't know why there's two set constants in there. That's kind of weird. Is it
Emit,
maybe
ar-
go on.
emit argument and queue nested if not in query. This is doing variable value const. Variable value const.
This is happening in a functor case, by the way. So this is nested, as the name implies, I guess.
Hmm.
Are you sure we're not getting confused because this is a query and then when doing queries the order gets upside down? Like you gotta remember this is a query. That entire thing of the example is a query. And I remember that the query and a predicate slash fact, they have the emission order reversed.
Yeah, they do.
Yeah, are we taking that into account by any chance?
Well, if not, then we should.
The thing that is kind of amusing is that master works even though the code is wrong.
Oh, that's because wasting heap space doesn't change the semantics of the rest of the program.
Ah, I see. Well, the only
Let me
thing...
try.
Go
Let
ahead.
me try something here real quick. If we go back to master for a second, because we know. Uh, let's just change this to run our example program, right? Uh, yeah, we know this works, even though there's that extra set constant up there, right?
I'm starting to think there is some place where we are matching the integer, but we should do a condition check instead. Like, for example, line 84. We know there's an integer in there, but I think we should not be always adding the instruction. We should do some sort of check beforehand.
Yeah, this one, right?
I don't know if it is exactly this one. We have this pattern matching on integer in many places in the code generator, at least in 2 places. So we should try to understand which place. But I have a feeling that this is the problem. There are some integers that we should not be generating because they're just gonna be wasting space. So that means that we identify the integer, we do a check, and if that check is not valid, we just put allocator, we're done. We don't do add instruction at all.
Hmm.
But then the question is, what would be that condition to adding it?
Let me try something here. If do we have? We do. If we are in query, then actually fun identity, and there's a then here. Else. Okay, that's not the
That
place.
yeah, that's not the place. But we have another pattern match on integer, like line 84.
Hmm. Oops. Emit argument and Q nested if not in query.
If not in query, and we have the in query in there, that's kind of funny.
And then emit single queued argument.
Yeah, we also have the matching there. You see 129.
Yeah, no, but this one is for a queued argument, which means this is for the. This is definitely for the inside of.
Of a
Although
function.
this still uses put structure and get structure. Is that a problem?
Oh, this code works. That's all that I have to say.
This takes the inquiry, doesn't it? It does. And that's in the generator. If we do if inquiry, then identity else. If we do it here,
Damn! They're gone!
um,
Wait, run the program. Let it run. Yeah, this works. And we remove the wasted space, so it was there. Magic. Magic.
hmm.
Yeah, but we should run the other programs as well. Like the other test programs. Because that's pretty substantial.
Okay, let's try.
Man, we really need to make a PR adding this test suite. So just do Doom test and everything runs.
Let's try factorial, right? Because that's the one that uses the most stuff.
Yeah. And it works.
And it works.
Well, I would also try the minus as well. I think minus is using like literals. Yeah. And in a query as well. So that's gonna be pretty nice to see how it behaves.
Let's try the minus.
This is 6, yeah, because it's 4 minus minus 2. So that's correct.
Yeah, that works.
Stash these changes and go back to our branch. We solved one tiny problem, which is we're not generating useless stuff.
I don't think this is quite going to.
Fix the other problem, I agree. Okay, there is some shit here. Oh, it's because we added the fucking functor. Okay, so put line. Uh, I moved it. Okay, I'm regretting it that I moved it.
No, this is actually pretty easy. I just have to do this goes here, except this can go here. And then we have to do the same thing here, except it's for an atom instead of an integer. And this can go away.
That's not. Actually, that was supposed to work. What's the problem?
The problem is
Maybe
probably this. No,
no.
it isn't.
I think you need parentheses. Yeah, I think we need parentheses on the else branches.
On the else branches. Why?
Yeah, I have no idea, but something is telling me that we should.
No difference.
What is the output of add constant?
The expression has type t2 cell machine store register allocator.
Returns a t2 register allocator and the store. What is the input for these things? Oh, the order is wrong. That's the problem. That's exactly the problem. No, open the LSP thing. You see that the third argument is t2 store and allocator, and the outcome is the allocator in the middle and the store at the end. That's the problem. Yeah, we can just we're gonna have to either swap how add constant works, and I think that's better. It should receive the it should yeah yeah. So swap the allocator in the store. I think yeah. Swap the order of those two, and then down there swap it again, and then the identity will work, I think. Okay, now every single place is fucked. So now you need to swap it out. Yeah, the compiler will tell you. Line 90, just swap them out. Compiler 137, same thing. Oh, this is actually the place. Okay, so now you just do this final swap. Well, maybe you're using this in some other place as well. I don't remember. Okay, next. Compiler. 217. Same shit. Boom. 317. A lot of 17. A lot of sevens. Boom, boom, boom. Maggot, are you there?
Castelo
Yeah, I
Rá-Tim-Bum.
am.
Man, I'm reading the Leaning Tower of Babel.
Okay, and what about it?
It's incredible. Like I had a chapter that I was unsure. Like, man, either this is the entire chapter is irony all the way, or Richard is saying some bullshit. But it was irony all the way. It was an entire chapter, ironic chapter.
He's a very man. You know what I find impressive? He has that kind of insight, and he has not gone crazy. He doesn't look bitter about it. Like most people that I know that are on that level of like clarity, they just go crazy, right?
Yeah,
Uh, I
it's
can
pretty
cite
good.
one, but I don't want to. But
It's
you
pretty
got the
good.
idea.
It's pretty good. Uh,
We're
well,
still doing a set variable next 5 for some reason.
set variable. Can I try running the program?
I am.
No, 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 just. Wait, this works. Is this on? We're not. Are we on master?
I no, we are in list.
Damn. So that was the fix.
Hmm. Just 1 second. We're initializing x4. Set constant. Set constant. We're initializing x0. Integer 1. Set value x4. Set variable on x5. But that's not really inside of anything, is it?
Yes, this is the query variable. This is x, no? Wait, did you save that? How this program is running?
I didn't save it.
Ah, okay, that makes sense. Yeah, I think the
Yeah,
set
this.
variable is the x. Yeah, I'm pretty sure. The one on line 7, that's just for the memory reading later, right?
But that doesn't make sense because we shouldn't touch that until this point, actually.
Well, but it works. I don't know how, but it works there.
Query variable. Let's see.
No, but this is only for the memory crawling, right? So like the query variable, I don't think it matters that much. It's the set variable that you're wondering, right? If it's correct.
Yeah, let's see. Um, yeah, if we're in a query, in this place specifically,
Which is the place of a variable.
yeah, for this place specifically, if it's a variable, then actually we shouldn't. Um, yeah, we really shouldn't actually.
Are you sure, man?
Yeah, we just need to make this a little bit bigger. If hmm, actually no. If we're in query, yeah, this is a mid single queued argument.
3 places.
Mm,
Once again.
here, here. Wait a second. And here.
Wait a moment.
And then
Is the problem that this set variable is doing nothing then?
it is doing nothing, yes. Actually, it's
Ah.
wasting heap. Actually, technically, it's wasting heap space.
Yeah, I understand. So we need to do the same shit. We need to find a place. We need to find a condition and a place that we're putting it. That's essentially it.
Hmm. Yeah, this is the place, indeed.
What's going to be the condition?
Actually, just for the sake of making sure we don't mess it up, we're doing this here. We're doing this here, which is in... Yeah, this is the place that we're changing. This is the place we didn't change. And this also we didn't change. So it's actually just here. Um, yeah,
I'm
just
getting
becomes
dizzy.
this.
Sorry, Mageto?
This goes away.
I'm dizzy with heat.
Oh, but is it also hot where in São Paulo there?
It's infernal, man. It's horrible. Is it hot where you are, Marinho?
Um, kinda.
Ah,
I'm
man,
waking up at
it's
6
unbearable.
a.m. because I'm sweating in my bed. Like literally
That
waking up
sounds
naturally.
fantastic, Lemos. Thank you.
I'm waking up naturally just because of how nasty I become.
Ah, that's horrible. I wouldn't, man. I would not like to live where you do, especially without an air conditioner. That sounds insane.
Yeah. But wait, we're gonna make Marinho lose his track of thought. Go on, Marinho.
But actually, we shouldn't do this if we don't emit the instruction either. Yeah, it's actually easier to just do this, I think.
Do what?
This can go away, right?
No, but depends. You removed the query variable.
Oh, yes, but let's see. For register, seeking registers
I thought
instruction.
the problem was the set variable.
Well, well, the query variable follows the set variable here only because the set variable exists, but it shouldn't.
But you are still doing the add instruction, right? Isn't
Hmm.
instruction the set variable?
Oh yeah, this is backwards, actually.
Okay, that seems like a pretty huge change. We just swapped the conditions. Okay, try to run the program. Let's see.
There's one small issue still. Yeah, this register marking here is the problem.
Why? This is the same as we always do. We check the scene register, the registers. If we
It's a
haven't, we use
problem.
variable function. If we do, we use
It's a
value function.
it's a problem because if we remove this instruction, but we still do this, then this instruction will be a set value, which is wrong.
Well, to be a set variable in the future, right?
It should be, yes. And in order to do that, we need to actually do something kind of like this, I think.
Isn't just putting an if surrounding the entire sheet enough?
Yes, if we are in the query, Then we just return generator allocator store. Else we do this, and because we already know that we're not in a query, that means we can just do this unconditionally here.
There's an extra space before add instruction. Let's go.
Okay,
Let's see the
that
code.
works. And the code,
It is using less. This is 17 cells instead of 19.
cons set constant atom new
Damn.
cons set constant set value x4, which is initialized.
Yep.
Cons set constant set variable and then query variable.
Yep.
And then we call equals.
Phenomenal. You should commit that.
No, we actually should test this more.
No, but I think we already did a lot of... Oh, test with the previous programs, that's fair.
Okay, that's 120. Let's try lists. That one was broken, right?
Yeah, but that's a separate problem, I believe.
No, this unification was broken.
Yeah, but this is specifically because of the list semantics. Functors with no name and narrated true, they have special treatment. We're gonna have to go over them.
Right. Let's just try for the sake of... Yeah.
That also doesn't work.
That also doesn't work. Why is that? Debug.
Remove the single quotes.
They shouldn't matter, actually.
I know, but no.
We're putting a cons, set constant 2, set constant atom empty, which is what we expect, right?
Uh-huh.
And we put another structure, and this goes on register 0. We add the 1.
There are too many cons in here. This is not helping. Let's make this example simpler. We're gonna have a lot of registers that are being used just because we have 4 cons in here. Let's make it simpler.
Okay, let's do... I don't know, let's do...
Swap the second cons with empty list. No, the entire, yeah, that, and swap the last with X.
And
just
this
X.
is X, right?
That also works. See if the program explodes first. Yeah,
It
okay,
does.
so now we go. This is still, yeah, okay, comment the other definitions because this is also fucked. Comment the append and the add. We don't need them anyway.
Oh, this doesn't work because of the dots. That's very sad.
Yeah, just use the line comments. Just use the line comments or the expression comments. That's not how you do comments.
Wait, it's using hashes for prologue. That's silly.
Oh, your mode, you mean?
Yeah, it's percent.
Yeah. Okay, now let's run the thing.
So I call Cocoon thingies, modes.
It's not a mode, actually.
What's the name? The correct one.
What's the correct one? Technically, let's go to... Oops. KRC. Well, we just set the file type. That actually runs a bunch of hooks that...
Oh, so it is kind of like a type instead of a mode. Okay.
I guess technically people do call it modes for the different languages, but... Like, that's not a general name, in fact.
Did I see an option called the murder Clippy?
Yeah, that's exactly what I thought.
Oh, there is actually a reason for that. You see, if I comment this line and I open a new instance of Cocoon, do you see Clippy right here on the
Oh,
left?
Oh, it's
yeah.
a different Clippy. You guys have your own Clippy.
Yeah,
Okay, okay.
but
Looks
that takes
cute
up
though.
space. Yeah, it's cute, but it takes up space, so that's why I murder him.
Yeah, Marinho loves to use half of his monitor, Mageta. So that's too much space being wasted.
Well,
Okay, but now we only have 14 instructions to read. That's way better than 68. So
Okay, so
cons,
put structure cons.
the one, then the atom, another cons, the x, set variable, right? Then the query variable that goes with it. Then the final empty string or empty list set constant, and then we call equals. I don't see any problem. Do you see a problem?
Then we call equals. And then equals, we just do get variable, get value. Yeah, that's normal.
How are we having a
Then we
free
call.
variable?
Well, apparently we're not binding the variable correctly when we unify these two.
These would be unified as functors, right?
They should be, yes.
So what the fuck are we doing?
What happens if we do this, right? Because these are not lists anymore.
Yeah,
That also
which
fails.
there, yeah, that's still that. We are
Hmm.
so fucking close to the previous example. How is this broken? The previous example didn't have single quotes, right?
That shouldn't matter because
I
it's
know
the,
it
like,
shouldn't matter. I understand. But I'm just trying to count the differences, just to see what the fuck is going on.
that still blows up.
That's still
one
free
sec.
variables. That doesn't make any sense. I don't know, put instead of x put 1, and instead of new put x on the second cons.
Like this.
Yeah. Oh.
That actually works.
Okay, so there's your problem. For some random reason, that breaks.
So the problem is unifying the number, not... Huh. Okay.
No, we don't know that. Put new instead of 1 in the first cons. I thought it was positional problem. You said it's because of... No, not that. New. Yeah. This points to a positional problem, right?
Yeah.
How? Do me a favor. Put another new on the first cons and put a new before the x.
One, two, three,
1
new.
x. No.
Actually, this is
1.
gonna break, right?
Yeah, 1
One,
comma. Yeah, and then 3.
three.
Yeah, run that.
That breaks.
Okay, so only works at last position.
Hmm.
It doesn't work in any other position. That's a very particular bug. And I'm very surprised we haven't catch it before.
Hmm.
Yeah, so this is a positional problem. Okay, let's look at the generated code.
Actually, before we do that, let me look at the heap. Right, so we have a functor cons with 1, 2, 3. Then we have another functor cons with a reference, a
And then
free
it should
reference,
free.
in fact.
Yeah, but that will not be free after unification, theoretically, right?
It should not be free at this point actually,
No, really.
because this is this debug, which is after we handle the arguments.
No, but this is after unification as well then. So the unification could
Yeah,
be fucked. Maybe not, it is fucked.
and if we do x and 1, and we halt, and we print the memory,
It's already arranged.
yeah, it's already bound.
Okay, so unify something is fucked. Which one? And how did we how again, how didn't we find this before? That's so weird. It's not really even related to constants at all.
Okay, but before we get into that, we did fix the instructions being incorrect, right? So we
Yeah,
should commit this.
you should commit that. You should commit that.
I am in lists. Okay. Page. Yeah, let's remove things from staging. Okay, what do we have? We have we swapped the order of the thing and fixed that everywhere, and then yeah, these are the big changes.
Big changes.
Hmm. And everything else is just fixing the order of the thing that we changed elsewhere. Yeah. Fix code generation when emitting constants in query. Right? Actually, for constants in query.
No, not even constants, but like we also fix it for the variable.
Um, yeah, for variables nested inside of functors specifically, right? Functor arguments
Yeah,
in query.
I would
Because
say no. There is a typo there.
that's yeah, there's a typo. Because that's the general case, the actual general case.
That's true. That's true. Slowly
Git
but surely.
push.
Okay, so now what we gotta discuss, we gotta figure out. Okay, so the code generation, is the code generation correct? I don't know if we settled on that. I think we settled that it is.
It should be, yes. Let's just, for the sake of our own sanity. Oops. Uh, yeah, let's comment this and let's do. What was the original program? Oh, it was this append, right?
Not really an append, but
Let's
this
just
is.
restore that actually. Yeah, this, and then we have this. Dune, exec, Karuta. 1, 2, 3, 4. And if we add 1, 2, and 3, 4, we get 4 and 6, right? Okay, that's still working. Right, so next is we need to figure out the unification issue, right?
Yeah, we should make an EQ file again. Put the example there.
Well, it's here still.
Yeah, but this is one that works. So
Well, we know this should break, right? On the X specifically.
this is
So
too
main.
complicated. This is a too complicated example. Let's simplify it again. Don't need all of this nesting.
Okay, this can just be new then, right?
Yeah. Hey,
This actually
what?
works.
Go fuck yourself. Okay, swap the Y for new.
And that breaks.
Okay, even worse. It works if you have two variables. If it works if the variable is the last one. Terrible. Terrible, terrible, terrible.
Um, you know what we should do actually? We should do. Okay, here's what we should do. We should do main A B debug and then EQ A B and we call main instead of EQ, right?
That's fancy. Well, I think that's worse because it's going to generate more code for us to pay attention to.
And we don't need this debug. We just need the first one because the point is, um,
Now we
if
can
we
take a look
turn
on
on,
the state machine before calling EQ.
yeah, if we turn on the trace actually, we can look at things before we call the equality predicate.
Yeah, I see
So,
value on that.
okay, X registers, they are kind of as expected. Memory is, we have a const with one and a new, and a const with a free variable in the new. So everything is fine. So if we do a step, that's put value, and the registers are actually still the same.
Mm-hmm.
Then we tail call EQ.
Mm-hmm.
It's going to do a get variable from x0 to x2.
And
x0 to
yeah,
x2.
this is essentially a no op with the put value from above, right?
No, this is inside of EQ actually. This is moving, well, this is allocating a new variable on x2, which is actually the same as x0, which is a no op
Yeah,
because
yeah.
of previous garbage on the registers.
No, it's because of the put value.
And then we do a get value from x1 to x2, which is unifying the two variables.
Yeah.
So if you look at the memory now, um, we're doing a get value from x1 to x2.
Yeah, the reference is still unbound.
And then we proceed. But that means the get value is not actually unifying the two.
So let's go to the evaluator and get value. Ah, of course. So this calls the main unify. Because of course it does. Okay, so which case is going to be this case? It's not going to be true references, right?
It will be actually.
So is bind wrong?
Actually, no, it will be, we're unifying two structures, in fact. So we are unifying two structures, and we did actually change this recently, right?
No, no. We added a case for lists. That's true.
Mm,
Ah, no, 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 no. I remember. You're right. we changed the functors on 175 to structures because therefore deref cell is being used instead of deref. I remember. I think this was using functors before. But now it's only using structures because the functors are supposed to get away when you're calling deref cell.
We also changed these two, right? Because
No,
PDL
those,
push now takes a reference.
that is also true. These were taking values before instead of whatever. No, but then that means that we're gonna do reference to reference at some point, right?
Yeah.
We're doing a loop with this changed. So maybe the bind is wrong? I find that very hard to believe. Very hard. Let me go to unify in the book here. Man, this function is so fucking busted. We always go back to it. Okay, so in the case they are both structures. Uh, we do a store get on them. That's true. We check if they are functors in the store, and then if their names and the arity needs to be the same. Yeah. Then we call ourselves doing a fold pushing. Yeah. Pushing the first one with I and the second one with I as well. But in our case, we're pushing references instead of doing what this guy is doing here. So yeah, seems to be. Well, we are kind of reversing the logic a little bit because in here, I think it's better for you to take a look at it because I don't trust myself on these De Morgan reversals. 131.
131.
Yeah. So if you scroll down here, the case of structures, we are doing De Morgan on it, right? Because we're doing difference and an OR, right? So we are doing equals on an end.
Yes, we are. If
So why is this only fails with this case? That's what I don't understand. If you put the y with the x, then it works. But if you put only x, it doesn't. Why?
because if we put the y, we fall into this case actually.
Ah. But aren't we already gonna go there anyway? Because you're pushing to the PDL a bunch of references, and then we are popping from the PDL in the beginning. So we're gonna go there anyway. No?
We should be, yeah. Okay, if f1 is different from f2, or well, if the names or the arities are different,
We just fail.
then we fail. If they are both respectively equal to each other, then we enter the loop, right?
Yeah. Can you go to bind for a moment?
I can go to bind, I suppose. Bind.
I was kind of counting on that we had a less than equals instead of a less than in there. But we do have a less than. So fuck me. Fuck me. Wait a moment. Reference A1, A2. So what does, yeah, this needs to be taken carefully because this is very different than the book. Because we're using pattern matching, we're not using the ifs, the nested ifs. You should take a look at it. 128.
Uh, Not deref, bind, right?
Yeah. So if the first one is a reference and the second one isn't, or
Or A1 is less than A2 is less than A1, right?
yeah.
So if the first one is a reference and the
The
second
second
one
one
isn't,
isn't.
we do this.
Wait a moment.
If the first
Wait.
when the, okay,
Go back to the code. What are we doing? We are putting on T2. We are putting on T2. This is so fucking confusing. Okay, we're putting on T2. That makes sense. That's the store A2. We're putting. What is the order of put? Is that the address
wait
first?
wait a moment, wait a moment, wait a moment. I'm thinking here.
Yeah, that's
The first
exactly the
one,
problem.
no. If the first one is a reference and then we have this thing here. If T2 is not a reference or A2 is less than A1.
Yeah, I think we're doing that part wrongly. Because we are only checking the inequality if they are both references. That's not what's written in here. I think we're missing a second when clause, a second guard. Yeah, yeah, go back. I think the guard is in the wrong pattern matching. The guard should move from the first pattern matching to the second. That's the problem.
If T1 is a reference and if T2 is not a reference, we don't care about the inequality. But if it is, we do. If it is, we do. But we actually need to do a check here that when um,
Yeah, that's a problem. What are we going to compare these things to?
we have a not, right?
I don't remember if that's how you do not, but we do.
Not.
Okay. No, but if the first one is a reference and the second one is not a reference,
No, the problem, Lemos, is that if the second one is a reference,
then we care about the
but with
guard.
no. If the second one is a reference, but we fail this, we're still gonna hit this case anyways because we didn't have a guard here.
I think we're getting. No. Actually, the references are holding the addresses. Okay, so I think I'm starting to understand your thought process. So if the first one is a reference and the second one is a reference, then we care about the guard. Okay. Wait a moment. I need. Okay. If the first one is a reference and the second one is a reference, then we care about the guard. If the first one is a reference and the second one is not a reference, then we don't need to care about the guard. And if the first one is anything but a reference, then we need the H2. I have a feeling this is not a catch-all, this one on 93. Because what if the second one is not a reference as well?
Well, if the first one is not a
We should
reference and the
fail.
second one is
We should
not a
fail with an
reference, this
exception.
should no, this should just well, this is
No,
wrong actually because bind is supposed to take two variables. Oh, or rather, at least one variable, right?
no. Bind is supposed to take only addresses. We're taking references because we want to reuse, we want to cellify everything for the sake of deref cell. So what we decided is instead of sending addresses, integers to this function, we upgraded them to cells, but we want to make sure that they are references. This is a constraint that we put ourselves. The bind function, the original bind function, only deals with integers.
If T1 is a reference, if T1 is not a reference, we always follow on this one, right? The second case.
Exactly, but we are not doing that. We are doing a catch show on the first, but assuring that the second one is a reference. We should have a catch show that goes to a fail exception. We should have a fourth case that if the first three ones are not followed, we should fail. This is a compiler error. Because it doesn't make sense then to not be references, right? We are using the A's and ones and the A's twos in here, and they come from the references. If we have anything aside from true references, everything is just fucked. Actually, I said it wrongly. At least one of them need to be references. The other one may not be.
Bind. Yeah, those are all numeric stuff, which we have to test later.
Yeah, but now I'm a little bit worried about those because those are using things that are not references.
Okay, this will always take a reference as the first argument at least.
Yeah, so that's fine. We need at least one reference. That's the kind of what we are assuming here.
This will take D1 and D2, and this guarantees that at least one of them is a reference as well.
Yeah, but we changed the function. We should test the program again.
One second.
You added a guard.
This is being given a reference, always, on the right-hand side.
Both are references.
In this one.
Yeah, you have a reference on line 111, and a reference that you're creating yourself.
Yeah, they're both references. And this is numeric code, which we can check later, but for the most part, let's see. If this is a constant, this is guaranteed to be a reference, and this is guaranteed to be a reference. Those are fine. This is sum. This one is for negate integer when cell is a reference, so that's fine. This one takes product is a reference in this case. Cell is a reference in this case. Okay. This one is for the quotient, which is a reference here.
Mm-hmm.
And remainder is also a reference.
Mm-hmm.
In this one, the remainder is a reference.
Mm-hmm.
So binding the remainder is fine. In this one, the remainder is not a reference, actually.
Yeah, that's actually true. The remainder is a constant in this case.
Yeah, this is wrong. This should be the quotient, actually. Yeah, because we're just doing this division right here, right?
You're right. That was my mistake.
And in this one, we're binding the remainder, except this is not really, this is the divisor that we're computing, right?
The divisor is the reference, so I'm gonna guess the divisor as well.
Yeah, because we have the we have the dividend, we have the quotient and the remainder, so we can derive the divisor in this case.
Yeah, no, this was my mistake. Well, we didn't make programs to test those instructions. We just made them. We should have done that.
And then this one
It's
is
also wrong.
binding the remainder, but it should bind
Whatever is the
the
reference there.
dividend actually. Yeah, because the dividend is the divisor times the quotient plus the remainder.
Yep, let's continue.
Yeah.
Okay, so we are
Yeah, that's the last one.
okay, so you are convinced in the bind, if neither of them are references, this is a compiler error.
Yeah, this should just fail. And this is not going to be a compiler error actually, because bind runs at runtime.
No, there should be a fail with. There should be a catch-all in here. That
Wow, this is just gonna blow up in that case.
no, it won't, because this will be a non-exhaustive pattern matching, right?
Which blows up, right?
Now, yes, that's not going to be a nice error message for us, but okay.
Okay, if this is a reference,
And the second one is a reference, then we need to care about the guard. That's true. The second one, if the first one is a reference and the second one is not a reference, then we do that as well. And finally, if the first one is not a reference,
the second one must be a reference.
that's yeah, that's actually true. Or actually, or the inequality. Does that matter? It does, right? This is a logic AND. So it must be not a reference. It must be a reference, and the guard need to be false.
Well, if this is a reference and the card is true, then actually we're gonna hit this case.
No, because the
Oh.
first one is not a reference.
But if the first one is not a reference, then this will be false, which means we go to the else branch.
No, yeah, but that's what we are trying to compute, right?
No. If the first one is not a reference,
No, I'm
this
tired. You're
here
right.
is an end.
If the first one is exactly, if the first one is false, the entire shit is false. I'm just stupid. Okay, let's try to run the code because we added a new guard to this function. I don't think this is gonna change anything, but
Fail with bind should receive
at least one
at
reference.
least one reference.
Exactly. Let's run the program. I don't think this changed anything, but yeah.
Should do. Take care of free variables.
Yeah, this happens because probably it's still a free variable after the unification. So the unification is still broken and it's not the bind the problem. I'm glad we did it because we discovered a problem with the other functions that we were using bind, but that's not where the problem resides. So it's inside the evaluation still. The evaluation, the unification, but it's not really clear to me where.
I think we can commit this, right?
Sure.
Fix bind.
Wrong uses of bind, I would say. Those functions would blow up if they were ever called.
Also fix bind guards. Right, memory. Let's turn on the trace. Put value, deallocate, tail call, get variable, get value, and now we should have memory. Yeah, still unbound. Proceed, and then we halt, and that's wrong. Okay, so what's happening is we have a reference on one side and a constant on the other.
Can we read the deref cell for a moment?
Deref cell.
Okay, so in the case of a reference, we deref the address, and if it's a functor, we just convert that back to a structure.
Yeah.
If it's a constant or a list or a structure, we do nothing. Because if you look at the memory, what we are actually trying to unify in this shit is a number and a reference, right?
It's a number, which is a constant, and a
And then
reference.
and then
Yeah.
like a free variable. So then the free variable should become the number, right?
It should, yes.
Wait a moment. Okay, go to the unifier now. One of them is a number and the other one is a reference. Do we have a case for that?
This case.
No, this is the case where, at least one of them is a reference. Put a print in there.
Okay. Um,
No. You should materialize the addresses of the references and print them in here. We should see 1004.
got here with address, and then we do string of int
Yeah,
address.
something's fucked.
I think we need to do this.
Makes sense. Let's go. And put the trace back, the trace on first. This should happen immediately after the get value, right?
It should, yes,
It's
but
wrong.
it didn't.
Okay, so we are not going here.
Let's put a inside unify.
Also print the D1 and the D2 before the if on 172.
Okay, so D1
There is a
is
cell.show or whatever. And then you do the same. Well, you can concatenate them if you want.
D2 cell dot show D2.
And that's it.
Yeah, actually, let's put those on separate lines. That's probably nicer. Print and line at get rid of this comma. Oops, print and line.
Yeah.
Turn on the trace.
Go.
Put value deallocate execute get
Now.
variable.
Okay, now we're talking. Okay, so we did 2 turns. But there's no 1004 in here.
Ten
Wait a
oh
moment.
three.
No. Let's see the memory. Print the memory. Okay, so 10. Okay, so 1000 with 1003. That makes perfect sense. And we have the 2 news. What the fuck happened with the 1001 and 1004?
Hmm.
Are we missing the PDL push by 1? Or something? 195. Are we missing the fucking Chapeuzinho on the dash dash? Because of the whole inclusiveness bullshit?
Enumerate numbers.
Oh, this is the inclusive one.
It is inclusive, yes.
Fuck me. It seems like it, no? Because we did the cons. No, but we jumped the one. We didn't do the. We are not missing. We're skipping. How is that possible? How is that fucking possible?
Structure 1000 and 1003, but we're not actually unifying.
The 1001 and 1004. I don't understand how that's even a thing.
Hmm.
How? How are we skipping it?
Can we run a REPL in OCaml?
Uh, with Opan, we would be able to. With
Do
Dune, with
new top.
Dune new top.
Like this?
Yeah,
And it is bad. I can.
tabs
I,
don't work, by the way.
what doesn't work?
Tabs. So you need to type things.
Oh, so even just as bad as the vanilla closure repo. Cool.
Off. Actually, this is the wrong. Let open batteries in list.off enum.
Oh, you want to test if the syntax is if the LSP is lying.
1, 2. Let's do 2 in this case, right?
Sure.
Um, except
Semicolon.
semicolon. Yeah,
Great.
that doesn't really.
Oh, you need to bind that to something.
Okay.
I
Oh
don't
wait,
remember
what?
how.
Let opening list of enum is an expression, right? In
It is
itself.
an expression, yes.
That should work.
But is it semicolon that you
Oh,
put
double
in there?
column, double semicolon. By the way.
Double semicolon.
There we go.
Yeah, that's an int list.
And it
1
is
and 2.
inclusive. And it is inclusive indeed. In the book, is it inclusive? I don't remember. Let me check. The answer is. Well, with this pseudocode syntax, it's hard to tell, but it seems to be inclusive, yes. That doesn't make any sense.
I'll be right back.
How are we skipping one? How is that even possible?
Computer with store equals, fold left. There's the list of enum.
I'm
Oops.
so fucking confused right now.
We do 1, 1. Okay. We do 1, 0. Not 1, 9, 1, 0. That's an empty list, which is correct. If we do 1, 3, that's 1, 2, 3.
Man, we must be smoking something wrong in here. There's no way. Can you? Yeah, it's not even printing in the D's there. It is not even printing in the D's.
Okay, let. Um, hmm.
Go to line 190 and put prints of the values of A1 plus I and A2 plus I, please.
Uh, Wait a second. Wait a second.
Yes.
If we match the D reference to D1 and D2. Oh, but we're dereferencing D1 and D2.
Yeah, no. When we do go to the first two structures, we should be having. We are pushing to the PDL the 101, the 1001 and 1004.
Um,
I want to print what we are trying to push to the PDL. That's what I want to try. Can we try that?
we can. Let's do it.
So you go to line 190 and put prints and lines on A1 plus I and another one for A2 plus I.
Pushing to
Looks
PDL.
it doesn't need to have a reference in there, but
Yeah, no, we know that's gonna be a reference. String of int.
and the same thing for A2. Let's go. Let's just go over with the trace on. What in the actual fuck, man? What a bug. There we go. Pushing 104, 1004 and 1001, 1005 and 1002. So we are pushing them. Okay. That means that the popping may be wrong. Yeah, it's PDL pop over there. Okay, I want to add more prints. I want to print P1 and P2. Fuck it. Agree?
Yeah, we can do that. But
Because I'm starting
actually,
to
before.
think that the problem is either PDL pop or deref cell.
Hmm.
I don't know which one is worse, to be wrong at this point. P1. Wait. Why are we... What? It is the pop then. Right?
Pushing.
We are jumping.
1004 and 1001.
Yeah,
And then 1005 and 1002.
Exactly.
No, but this is pushing. We're supposed to pop them in reverse order. That's fine, actually.
Well, but then why are we stopping?
Because apparently we think the PDL is empty at this point, for some reason.
But it isn't. Is this a minor, a one error, one type of error? Like we have one extra? I don't understand. Go there.
Hmm.
Let's read PDL pop and PDL push.
Wait a second. We loop over the prepared computer, which means which means we print these before printing the pushes, which is actually correct. Then we push the pairs, then we pop the references, which are the references to the news. But then we check if the store, if the PDL is empty. Wait, that tail calls loop.
Ah, there's another alternative. We may be failing as well. We may be failing, and when that happens, the entire shenanigans goes to shit. Wait, we were missing a loop in there, right? We just found a problem there.
Yeah, this needs to loop here actually.
Probably parentheses. Or that. Ah, so there were some cases in which... Yeah, but in that case we're gonna fail equals true. It doesn't matter actually in that case.
Loop
This one
here.
matters. This one matters. This one doesn't matter because the fail is gonna be true anyway. And the one above also that doesn't matter. The one, not the one immediately above, but the one above that. Yeah, this one that you just changed the loop to be outside of the if, this doesn't matter because the else is a fail equals true. So we're gonna get out of the loop anyway. This is just being less efficient. The one in 181 makes sense. The one in the least case makes sense. Just this 186 case, that to me it could be optimized away. But that's fine.
We pretty much always tail call loop. So what if we just do this? If D1 is different from D2, then else loop computer. Yeah, this is the if. What if we just loop here? And then we can get rid of all of these.
This has been making a lot of places inefficient because they are fails equal true. But that's fine to me. You're missing some more places. Go scrolling. Yeah, the 205. And it is what it is now. Oh, 218 as well. Are you putting the loop outside of the if or inside of the if?
It's outside of the if.
Okay, so in that case you can also remove that one. Well, let's test it. I don't think that makes a lot of difference in our case, in this particular bug, but let's continue.
Halt.
But this should be a possibility. We may be failing. And that's why we are getting out of the loop early. Okay, never mind. It was that. So in some other place, we were just finishing the loop altogether instead of calling ourselves recursively.
Yeah.
Okay, we can remove the prints. Actually, no, don't remove the prints. Go to the example, use lists instead of functors, and let's see if now the example works.
1 and x.
No,
Right.
I wanted one shoe and one x.
1, 2, 1 x. Actually, this was working, so
That was not working before, but well, we are using the special instructions now.
Let's do x and y. That's better. Let's do x and y.
Yeah, maybe the living boldly.
Deallocate, execute, get variable, unify because of get value. Proceed. 1 and 2. If we do 2 here.
Yeah, just that one. Just keep just let it fly.
Well, in that case, we can probably just get rid of the debug for now.
It works.
It's this, right?
Yes.
X is 1.
Let's go to the lists. Yeah, let's test this as well. Why not?
X is 2. Yeah, they both work.
Let's go to the lists example, and I think I commented out the case that I want to test.
Do you remember which one
Yeah,
it was?
it was 16. Definitely 16.
This one.
Yeah. We just test this, so it works. And we are just on time.
Oh. Yeah, we just did it. Okay, so we fixed the bug, apparently. It was a wrong... We were missing the loop. We forgot to loop. That's the problem.
Remove the print end lines from the unification now. We have more, probably. More prints.
Print and line.
You can remove the
We don't need...
addresses there.
Yeah, we don't need the addresses anymore. Um,
Yeah, remove those prints there. 188 all the way to 191. What do you have? Search for print end lines. Yeah. Bye. Oh no, this is the only
no,
print end line that should
this
stay.
yeah, no, this for the trace. It should stay.
Yeah. Dune FMT to format the code.
I already did that. My formatter, I configured actually
Oh, it already
Dune.
calls. Yeah. I
Not
also
Dune
do the
actually.
same.
I'm calling OCaml format, which is what Dune calls actually.
Yeah, this is. I do the same with. Actually, Rust Analyzer does the same with Rust. Okay,
Look,
so
look at this. This is beautiful. Actually, this is also pretty nice.
closure style. Okay, let's try to make more things with lists to make them break. Do you have anything that we can put in the lists example aside from append and add?
We have append, we have add.
What else can we try to make to try to break it? Because that's kind of our intention. We want to break it.
Mm, before we do that, we should commit this unification fix, right?
Yeah, you should definitely commit that. I'm very surprised we did all of those examples and none of them failed.
Uh, fix unification again.
Again.
Lists.
Yeah, here's the deal. We're gonna try to break it. If everything works, we're gonna say lists are done. And we're gonna go to the README and mark that out of the list. I'm very curious to know how you do a zip with in Prolog.
How do you do a zip with? Well, currently we can't actually because we don't have any
High order
way to
predicates.
call a predicate by name. Yeah.
I figured. Is that hard?
Uh,
Like, does Warren cover that in the second book?
I mean, we could make some kind of apply primitive that takes the name of a predicate as an argument instead of a predicate, because predicates are not actually values here, right?
Yeah.
But then we're restricted to only ever applying globally defined predicates, and we cannot return predicates. So
That's way less powerful.
uh, there's one function actually that I kind of like, and it's kind of fun to implement, which is well, in Clojure, it's called, and this is gonna barf a little bit, partition. Actually, let's just do the doc. Partition by. Not partition by. It's actually. Is it just partition? Oh, I actually don't have doc imported here. Closure docs.org. Partition. Yeah, this one. Yeah, this just takes a sequence and splits it into blocks, basically, of uniform size.
Wow. How do you plan on doing that in Prolog?
Let's think for a second. We need to let's just implement this case because it's a bit easier. We need to do something kind of like this. Partition.
Man, this is gonna be our lists library, right? After we implement namespacing. We already have 3 functions.
Yeah, this takes the length, and this takes well,
The
the
list.
source, the
Yeah.
list, and well, I guess
We don't have length.
the what do you mean?
No. We have less than equals, but we don't have a like list length. That sounds like a useful built-in for lists. We could
Oh,
implement it in
that's actually.
Prolog, but
I'm not. I don't care about the length of the list here, though. I care about it length, and then we do partition loop, which we need to implement.
you don't need to do it like that. We have atoms with spaces.
We have atoms with spaces. That is true. Fancy.
Of course. And this is gonna be where we're gonna put the initial accumulator, I believe, right?
Yeah.
We need to pass the length, I believe, as well, though.
Yeah, we need to pass the length. We need to pass a zero here. We need to pass
the accumulator, so like empty list,
an empty list and
and
another empty list and the list.
why do we need the second? Oh, we need the output as well. Oh, or the output is the list.
And we need the output, yeah.
And we need the output on the partition arity 2 as well, yeah. Okay, so now let's implement partition loop. What is the second list for?
Partition loop takes target. Let's just call it length actually. Accumulator length. Actually, let's call it
Inner length.
group length. This is the group that we're building.
Ah, one of them is for the inner group accumulator and the other one is for the outer one. I see.
Actually, do we need a second list? I don't think we do.
You don't think we do?
Yeah, no, I don't think we do actually, because we can do group length, group, and out. And then we do actually, let's do the case where the group length and the length are actually the same.
Yeah, that means that we just completed a group.
That means we just completed a group. We're going to need reverse actually. Verse.
That's very
In,
fancy, man.
out. Actually, we have a bunch of cases, right? The reverse of the empty list is the empty list.
That's a fact.
The reverse of an element and a tail and an output is
We're gonna call ourselves. So this is reverse.
Reverse
Yeah,
of the
the
tail.
yeah, the one with empty lists, by the way, you can remove the column dash above.
I think this is it actually, no?
No. I mean the base case, the line 11. Just remove the column dash. Make it a fact.
Make it a fact.
Cool.
Yeah, the reverse of the empty list is the
Is
empty.
empty, and the
The
reverse
reverse of
of
this is
something.
actually not. Actually, it's not quite this. It's we need to. We need to do. If you have an A and a tail, we have the output. Yeah, no, I think this is it actually.
Okay.
Except.
Except. Ah, that makes more sense because we are basically removing things from the first list and putting it back on the second
No,
list.
this is not right either. If we have an empty.
Are you sure? I think we just need a third reverse clause, which is what you wrote. Empty on the first, out in the second.
Um.
What's the problem, Marinho?
The problem is, I don't know.
No, we need a third clause for reverse because when we exhaust the first list, we're not gonna reach a pattern matching, available pattern matching anyway.
Reverse loop in ack out. That's the problem. That is the freaking problem. If we do a reverse loop where we have a tail, we have an accumulator, we have an output,
The accumulator should start as an empty list, on line 11.
it should be empty, yes. If you have an A and a tail,
Uh-huh.
then we reverse loop on the tail.
We need to put accumulator in
Uh,
there, and
this is
then
the
out,
accumulator,
and then
and then
out,
out,
and then we need another clause for reverse loop that is the base case.
which is the base case.
And then we should say out, out. Damn.
And this is just a
A fact.
fact. Yeah,
There we go.
you're getting
Reverse.
good. You're getting good at this, Lemos.
Well, I'm getting there. At some point, I will learn.
So when the length
Is equal
that
to
we're
the.
aiming for is equal to the group length,
We just finished the group.
then we reverse the group
Why are we reversing the group, by the way? I didn't ask that before.
because we're gonna build them backwards.
Ah, okay.
We reverse the group into an out group. Then we need to do.
Wait, there's
Then we
something
need
wrong.
to
No, there's
do.
something wrong. In line 18, we have 5 arguments, and in line 20, we have 4.
In line 18, we have 5 arguments because I did not remove this.
Okay. Are you sure? I think we are
Length
missing the accumulating of the group now.
length list out. We need the accumulator. We need the list here,
Yeah,
actually.
remaining of the list.
Yeah. We have EQ here, right? We're actually gonna use in this definition, so let's.
Agate, are you
I
proud of
guess we
us?
can.
We are writing
I guess
full
we can keep it
prologue in
there.
here.
What?
We are writing full prologue to make a list function.
Then once we have the out group, which is the reverse of the group, then we need to say that EQ out, the output is equal to the out group, and the tail of the output is the new out. And then we partition loop.
Why do we need the EQ? To me, we just tail call ourselves.
Then we're not binding the output lemons.
Ah, I see what you're doing. I see what you're doing.
Length 0, empty group, list new out.
Yeah, you could just put it in line in there, right? Instead of just making new out.
How?
Because... Oh, no, you can't. You need to unify that label with that. Okay, no, never mind. We need a
And I
base case.
forgot.
We need a base case where the least the penultimate argument is empty, right? That's the end.
Yeah, and now we have a small decision to make. It's not a very big decision, but it's a decision.
Don't care.
Group length. We have a group. We have an empty list, and we have an output.
Yeah.
Okay, here's the question. Do we want to keep the group, which is a partial group in this case?
Yeah, you mean that, for example, the length is 4, but the final group has only 3 members, right?
Yeah, do we want to keep it or discard it?
What does closure do?
Closure keeps it, I think.
So let's keep it.
Partition 4. 1, 2, 3, 4, 5, 6. No, it actually drops it.
Oh, so let's drop it.
Okay, let's drop it. In that case, then the output is just an empty list.
Yeah. Okay, so what else we gotta do? We need to keep like cutting the lists, right? We're not doing that.
Yes, we did a case for that. That is correct. So let's make a new case where...
Yeah, this is a list. The case that we have length, group list, out.
Yeah, actually we need to put this down here. If we have a length, a group, and we have an element, and this is out, tail. Yeah, in this case, we need to say we need to say add.
This is so much harder. Wait, add? Are you sure?
Group length 1 new group length.
Wait, that's not how you do add, friend.
What do you mean?
Our add takes 2 lists.
Oh, it's not add, it's plus.
Okay.
Plus group length 1. That's a new group length. Then we say partition loop with the length,
New group length.
the new group length, lm and group,
Yep.
tail out.
Damn, boys. Damn. Don't we need to reverse them as well? Like, because I think we are creating the groups backwards and them among themselves is backwards, or am I wrong?
That's what we're doing here.
No, but I think we need 2 reverses, no?
Why?
Actually, never mind. Let's just see the output. I don't care. Let's go.
We are already doing an implicit reverse here because we're adding the new elements to the beginning of the group.
Ah, okay, so that's what I was talking about. Okay. Let's call partition. Let's see if this works.
Okay, if we do partition, let's say let's use the same example we have down there, right? Out 1, 2, 3, 4, 5, 6.
I'm very scared right now.
Would you be scared, Lems?
Which program are we
Uh,
running? Which program are we running?
Not that one.
Okay. I'm scared because this is a very complicated program for our toy language.
And apparently that
It
toy
works.
language is working.
Put 2 instead
Oh,
of.
wait.
No, that's correct. Put
Hmm.
2. Oh no, but that's incorrect. That's incorrect. It's only doing one group. Where is the second group?
What happens if you
Uh,
put 0?
if you put 0, that should fail because we
Yeah, because of the less
constrain the
than.
length.
Exactly.
I see.
Well, we're gonna get out of memory, I guess, right? Okay, so what's the problem? What's the fucking problem?
Okay, if the lengths are equal,
Okay,
then we need to.
let's not do that. Let's try a reverse to see if reverse behaves as expected. Then let's go back to partition loop. Let's do this by pieces.
I mean, it must be, otherwise this would be backwards.
Ah, you're right. You're right. I think we can count the reverse is correct. So we called reverse loop, saying that the length and then the 0, the group
And then you
accumulator.
discover that the print is inverting.
That would
That'd
be
be
just tragic. If we are done with the input, the output is an empty list. That makes sense. If we have length, that means that we just completed a group and we have the input. So what we do, we reverse
Oh,
the group.
actually, yeah, no, this is wrong. This should be here.
Yeah, I think that sucks so much that the order matters.
There we go.
Look, Magetta, are you proud?
Let me see. Wait. Wait, what was the input? I didn't
Partition
see.
3, 1, 2, 3, 4, 5, 6.
Oh, interesting.
Come on, man, you must be proud.
It's kind of based actually. This is
Put 2
And it's
instead of 3.
tail recursive and everything.
And optimized. They call optimized. Put 2 instead of 3 there.
If we do 2, we get this.
Can you stress test? I'm just curious about that, by the way.
Sure.
Although I think you would, to be fair, like the comparison, it's running on top of OCaml, right?
Yeah.
So you would probably need to compile with a release. But let's try doing that. Try to do Doom, I think, release. Let's see.
Wait, but what are we comparing ourselves to?
Well, nothing. Just imagination. Use your
I thought you
imagination.
would say closure just for us to win, but okay.
Well, it could, but we have to code that enclosure. Do you guys?
Well, Marinho knows how
that?
to do that in
Yes.
10 minutes.
Then
What do you
it in 10
mean?
minutes. That's enough for me to discover the
What do
how
you
to
what do you what do
release
you
the
mean?
code.
Partition is in closure.core.
No, but you're gonna have to create an executable and stuff. I don't know how easy it
Yeah,
is to do that.
Oh, that's kind of annoying.
Yeah, that's what I thought.
It's the
Okay.
JVM. What did you expect?
But I want to win. I want us to win for a moment, okay?
Can you guys do that later? I kind of want to wrap up actually.
Okay, go to
Ah.
the README. Let's set. I think.
Just try doing this, by the way. Try to just do Dune build dash dash profile release. Just do that.
Don't build that dash profile
Release. And
release.
then yeah, like this. Just see if it builds or we need to add something. Oh no, it does work. It should have
Wait,
generated
but
a
there
binary.
is exhaustive checking in here for some random reason. Why that was not being told to us by the compiler?
That's a good question. I think the options don't apply, right, to the profile we chose. So it goes back to default.
That's
But check
terrible.
the build, Marinho. Like try to yeah. Ah, there you go.
Uh,
I think it's the install, no? Oh no, it's the default.
But
That's
there's a
weird.
default inside install. Bean?
Okay, that does not help. Um,
No. Call that program.
Manual distribution. You can simply copy the build executable in the default folder. So it
in
is
the
default. I don't know which one it is which, to be honest.
Well, this is doing what we want.
Yeah, this is doing what we want.
Yeah, I mean, but is it optimized? That's the question.
Ah, okay. So how can we check for that?
Yeah, but like for us to actually test, we would need to do some program that does that on a larger set, right?
But we can do that later. Go to the readme Marinho
I'm just interested
checklist
in
literals.
the memory usage, right? That's mainly the metric I'm
Ah,
curious
okay.
about.
No, we can do this right now. Marinho is gonna commit anyway.
Actually, that's kind of easy to check.
Go for it.
Uh,
Poop. That's phenomenal. Thank you, Marinho.
That is phenomenal.
Oh, I didn't know about this tool. It's cool. Let's see.
it's using at most 9 megabytes of
I mean,
memory.
but that's a lot still. I mean, okay, it's running interpreted, all that jazz, right? Um, can you add like more numbers to that, more possibilities, I guess? Like
You mean
Oh,
make this a large? You mean make this
yeah, like
bigger?
can you run a macro on Cocoon to add numbers until 1,000 and just put it there?
I could, but we could also just do this.
Okay.
wait. Ah, I see what you're doing. He's gonna use a tail
Uh,
recursive function to.
0 is the empty list.
We have a language. We don't need an editor.
And
Just need an
out
LSP now.
Sorry, Magetta?
Just need an
is
LSP now.
Yeah, and I need to
And an
put
IDE.
more. I need to put more things in there. This allocated memory is also counting the fact that we have virtual memory in the computer, in the virtual computer, and we have like at least 1 kilobyte of virtual memory. So that's probably also part of the culprit of 8 megabytes. Man, Marinho does programming so properly. He's even putting the less equals than in there.
That's a level of discipline I envy.
Yeah, but this is not going to be as efficient as just typing the numbers because you're going to have to do a reverse, right?
I'm not gonna
That's the
bother with
goal, I
that,
guess.
actually. That's why I
And the
named this
more we
reverse
use, the
iota,
better.
you see?
Yeah. What, Magetta?
The more we use, the better, right? Let me see if
Yeah,
I
you're
understand. So
missing the
you're
pipe in
doing
there. Yeah, exactly.
list construction, getting the head, and then if the head
And then
is
we need to
less
do
than less equal,
minus n1 n minus 1.
Does that
This
work?
it shouldn't actually. Let's do underscore.
Oh, okay. Are you missing a comma?
I am indeed missing a comma. That is true.
Okay, but what the fuck is this doing though? This is.
it's uh it's just composing a list, right? So the output would
Isn't it
be an
deconstructing a
expanded
list?
list.
No, it's building a list.
Yeah,
Building.
it's the opposite. Yeah, if you have any number, it's going to allocate that number and decrease, right? Adding a new element to the list, to the out.
But he's removing from the. Look at line 34. He's deconstructing a
34.
list that already exists and tail calling out in there.
No, I'm gonna do
I'm so
actually
confused.
main is
Cause that would yeah, I think that works. We tested this before.
reverse iota. Let's do I don't know 1000.
Yeah,
Uh,
he wants to ask which list fills that thing. You see, Lums?
He wants to ask
uh,
which
do we
list
care
does
about
that.
printing the output? We don't, right? We just care about memory usage
No,
at this
it's just
point.
yeah. I think it would be worse actually printing the.
It's
But
gonna take more
Partition.
time doing the syscalls.
but just
Let's
to have
partition
the.
it by groups of,
So
I don't
he's
know,
making a
4.
restriction of what is the number, like what is the list that can be generated out of this number. You see,
No, no,
that's
yeah,
the question.
yeah, I understand. My functional brain farted. That's the problem.
You're thinking of one-way functions, right? But
Yeah,
this
yeah,
kind of
yeah.
the inverse because it's a bijection.
Can we remove the open close brackets in there, or is that doesn't work
Uh,
syntactically?
we should be able to, actually.
I have my doubts.
Dune, exec, Karuta. It's not gonna... Right, we actually need to print something. Let's print out here. Not found. What do you mean, not found?
This is a compiler prob error. Uh, we are doing something very bullshit. I don't know what it is, but we are doing something bullshit.
Do you actually define the thing with steps with a dot, Maninho? Or is that like in Prolog with a semicolon on 33? I don't know the
33.
syntax you guys came up with. Yeah,
No,
because
this is
this
a
ends a
dot.
case. Okay, so it ends one case and then it defines the other, right?
Yeah.
Yeah, yeah. Yeah, but this is a compiler error. What Marinho just found.
Yeah, and that's
So
an exception in OCaml, which
yeah,
is
yeah.
the most
This
evil
is a
thing.
find. This is a find that we do somewhere. But I'm wondering what the fuck triggered that. We did partition, which is a way more complicated program, and it worked. And have iota is not working. There is no way that's the problem.
If that's it, that would be
Yeah, no.
funny.
Well, the error changed,
Yeah,
so...
which is worse. But
Oh no, but I know why. This is a... Probably this list is too big, actually.
oh, to the computer
Uh,
you mean?
put 50 then.
Let's do 100.
Okay.
Ah, what? What the fuck?
Huh,
Guys,
that's weird. That's very weird.
guys,
Oh
what the
wait,
fuck is going on?
if you can, that should be 25. No,
That doesn't
Right,
make
this
sense.
should... Yeah, this
maybe
should
4.
do... Oh,
Take care of free variables. How awesome.
there's a problem with the binding then. That's... weird.
But I don't understand. Partition loop is way more fucked than this. Right? So, what the hell?
Your powers have vanished, Lemus.
No, but this doesn't make sense.
You're defenseless now.
This doesn't make any sense. Do you agree, Marin, that there's nothing in here in your program that is doing anything special?
Not really, no, there isn't.
Take care of free variables. Which program are we running? Are we running lists in main?
We are running lists in main.
Okay, this is already. I think we're just too tired. I'm gonna finish the recording.